Azure DevOps with AWS with Jeffrey Opdam.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host, and make sure to check out www.azuredevops.show for past episodes and show notes. And I'm really excited for today's guest and for today's topic. My guest today, Jeffrey Opdam, is an ALM Ranger, which is a recognized group related to the Azure DevOps Product Team at Microsoft. And he loves doing crazy continuous delivery stuff with TFS, VSTS, and Azure DevOps, including coaching. He loves DDD, domain-driven design, and CQRS. And he also does software architecture, integrating that with DevOps. And most importantly, he's a proud dad. And he hails from the Netherlands, and you can find him on Twitter at Lean Phoenix. That's LeanPhoenix. And Jeffrey, welcome to the show. How are you, sir?
Yeah, thank you. And thank you for the nice introduction. And I'm doing well. How are you today?
Oh, can't complain. 2020 is off to a great start. And yeah, all good things. So you have a wealth of experience as a software architect and done some pretty interesting projects in your career. But before we kind of get into that, just so that people can get more familiar with you, what has your career journey been, and what things have led up to what you're doing today that's shaped you?
Well, I started as a developer doing C#, and doing some projects outsourcing projects for some companies in the Netherlands. And there's this defining career change where your mindset changes by somebody who explains something, where it's not more about coding, but more how you do things. And there's an overall view of things. That led me to become an architect. So you go from junior to medior to senior, then an architect. And somewhere in my career, I changed companies. And one of the things I got also involved is doing their TFS stuff for the company. And that led into learning more about Team Foundation System server, and diving more into ALM back then, and later on also into continuous delivery. And then I started making a career out of that.
Okay, awesome. So with your more current projects, as I understand it, you're doing a lot with making cloud resources in AWS do your bidding, and actually governing the DevOps environment with the Azure DevOps product, but then the software environments in AWS. Is that right?
Yeah. So the recent company I worked for has a AWS first cloud, essentially. Well, which is fine, but they want to leverage Azure DevOps as one of the promising tools for continuous delivery. So we need to solve that problem. And also, we wanted to get as close to where we deliver the software. So that's one of the reasons we actually decided to host the agents, our own, inside the AWS.
Okay. So you're using Azure DevOps. Now, is it Azure DevOps Services or Server?
Services.
Okay. So cloud Azure DevOps. And then all the agents are VMs inside AWS.
Yeah.
Okay.
Well, they call in the AWS, they call AMI. So
yeah, AMI, the EC2 instances that are okay.
Yeah.
So what? Just so we can kind of ground ourselves in this world. What type of system is the team working on?
Oh, it's we support about 500 to 600 engineers, and it's a financial company. So there are different kind of projects. So we have some teams are working on the website, and some team has just an internal application. The other teams have an off-the-shelf application that needs to install. We put everything through the pipelines. But we do have some restrictions about software, especially about dependencies. That's one of the things we want to tackle, so that we don't get dependencies from everywhere. And that's one of the decisions we made to have our own private agents, so we can control the network.
Okay, so this is not just one application, but this is a DevOps environment that you've designed and implemented for an entire ecosystem of applications for multiple teams.
Yes, true. So one of the things there considered that you want to have low costs, but you want to maximize the teams that don't have to queue all the time. So what we did is we took out the metrics out of Azure DevOps and translated that to metrics in AWS, which can be read by the autoscaling groups AWS has. And using those metrics, we started autoscaling our machines. So on-demand teams can grow based on the queue. We grew the size of the number of VMs for teams, so we can during the day serve them enough machines to do their work.
Okay. And so roughly how many builds, how many software applications, and then how many builds per day would you estimate that this runs?
So we started measuring the number of jobs, so releases and builds. So we last measurement I know about, we have around 600 builds and releases a week. And these are for around 200 applications. Okay. Different kind of applications.
And how are you integrating Azure DevOps with AWS so that it's done in a trusted manner?
Yeah. So instead of using usernames, we added a role, so an IAM role to the build server. And the other teams create a role in their AWS account, and they created translation from that role to ours. That meaning is that is our machine were able to talk to the APIs from AWS based on the role. So we had access to their AWS account, and they can define their roles. What kind of policies need to be? What kind of permissions do we need? And that's on their side. So they trust us to deliver their software.
Okay, awesome. That's one less credential for everyone to manage.
Yeah, and one less credential we can drop on the street, and everybody can misuse.
Right, absolutely. Now, this probably requires quite a few agents in AWS, and so you have one image, or how do you manage spinning those up and maintaining them?
Yeah, so we created a pipeline for a Windows machine and for a Linux machine. Use a packer to build an AMI. And that's also required for the autoscaling in AWS. You need to provide it an AMI. And then the autoscaling will take care of that. So it reads the metrics, you provide them, and based on the metrics, using the AMI, starts creating where needed. There is a feature in AWS is predictive scaling. So what we ended up into that we predicted 5 minutes before the actual need, and then 5 minutes before that he scaled up where needed. That was quite fun. So we are in time for demands, you can say.
So the logic for when to spin up a new agent lies in AWS rather than Azure DevOps.
Yeah.
Okay.
We collect the metrics from Azure DevOps. Based on that information, all the autoscaling is done by the autoscaling groups in AWS.
Okay.
And coming back to we're building the images with Packer. That means we kind of went to more immutable patterns. So we didn't have access to the machines anymore. We dropped that. So if there's a fault with a machine, we went to our delivery cycles, fix it in code, go to our test environment, set up, and then go to our production environment.
Now, before you designed and implemented this, what was it like on the teams? Because there's at some point someone said, "Hey, we can't keep doing this. This is a problem. We're moving too slow, or something's too hard. We need a solution." What was it like?
The teams used to use another product than Azure DevOps. Basically, everything was on fire. So we had daily problems firefighting the different agents were kind of static and solving those problems. We also have issues with unclean machines. So they get infested with somebody's code. By having the machines clean, it gets more predictable what happens with your code when you build. So we're kind of firefighting. At the end, we start firefighting out of that situation.
So architecturally, really, it seems like regardless if it's AWS or any other place, if you have a build machine that builds a variety of software applications or doing any kind of job on a variety of software applications, it's going to have temporary files and other things left over that can make the environment less predictable on any given future job.
Yeah, that's why you actually do want to have clean machines. So the host build server in Azure DevOps does it for you automatically. But if you have your private build server, by default, it leaves, let's call them undesirables around, and you do have to clean them in time.
Yeah. I'm reminded of the first time I read the Test-Driven Development book by Kent Beck.
Yeah.
And the principle was that every test, a test, it not only does something and validates something, but it also has to be responsible for setting up its own environment so that it knows that it's in a good state to do whatever the test is. And that builds are really just a big test.
Yeah, it is. You test it first. You test if it compiles. Well, the results you use as a package later on as a deliverable, but you do your unit tests, etc., etc. And and there are components on your machines that can influence the result of that. So it's also about being predictable, so that any given moment I can build a package, and an hour later is when I build the package again from the same source code, it needs to be the same thing, right?
Now, all of your pre-production and your production environments for all of the software systems, are they all in AWS or are they in a different number of places?
No, they're all in AWS.
Okay.
There are some on-premise, and our AWS accounts are connected on-premise, but we didn't touch that yet. So most of the parts what we did is also on the AWS.
Got it. Now you're in AWS for dozens of applications. What have you learned through automatically deploying a variety of applications with very varying architectures? And what have you learned about provisioning that you could share with the listeners?
I learned that I do have a strong preference for things like, first of all, you need to be able, when you have a central team within a big company, you need to be able to supply to different variances what the company needs. So some teams are doing lambdas, and the other teams are doing EC2 instances, and the other teams want to do Docker. You need to be ready for all of those. I do have a preference for anything making things immutable. So building Docker images and deploying that to dev test production, it makes things very stable and also predictable. And we use those kind of principle of we learned everything from Docker and we put them onto our AMIs using Packer. So I do have a preference to be able to deploy not applications, but I have a preference to deploy machines or Docker images.
Okay. And so are you deploying? I know you have dozens and dozens of applications, but if you were to say help a team get the next new application up and running, what would be your advice for them for the most flexible or most drama-free environment shape to choose in AWS?
In AWS, go for the Lambdas, especially you have smaller applications.
Lambdas, okay.
Yeah, and those are like the function as a service, right? Those are easy to deploy and to maintain, etc. If you second, I will go for the ECS instances, so like hosting a Docker image. Currently is getting better and getting close where it needs to be. I still stay away from Kubernetes on AWS.
Oh, stay away from Kubernetes.
Not Kubernetes itself, but Kubernetes
on AWS,
yeah.
Right.
I do love Kubernetes. Just it's not mature enough. It's getting close because they made little announcements a few weeks ago. But it's not that mature as what Google is doing or where Azure currently is.
Okay, so your first choice is Lambdas. If you have I guess a headless application that just needs to run in the background doing things, you're saying, hey, deploy it to Lambdas, and that's going to be drama free, low maintenance. For what about for web applications and for your SQL Server databases?
So your SQL Server databases can be so you can use the managed database on AWS. So that would be fine. And still, if it's an .NET application, still can run it in Lambda.
Okay, so put AWS in Lambda as well.
Yeah.
Okay. Sorry, ASP.NET.
Yeah.
No, SQL Server. Are you talking about one of the flavors of RDS?
Yes, there's a SQL RDS for that.
So you've had good experience with that for SQL Server databases?
Yeah.
Okay, awesome. Now you mentioned that you're using the Docker, that you are putting Docker images in there, but stay away from Kubernetes. Shed some light on the differences and why, if Docker images run fine, why would you even say keep an eye out for Kubernetes? What additional problem would you be going for there?
So is the implementation of Kubernetes. They currently are deploying that's called Fargate. Fargate is a plane underneath where you can see it as a pass offering, right? That you autoscale your nodes in Kubernetes. They're now rolling it out. So that's the part where we'll be careful. Currently situation, what I last checked, is I have to maintain all the nodes and do the upgrades and etc. So you have your maintenance put to yourself, where Google Cloud and as well Azure has solved the problem for you.
Okay. If you need auto scaling, then you need that solution versus just what you use AWS for now with Docker.
Yeah, and the ECS has that already implemented, and that's all solved your auto scaling problem on that point. They're just moving it into the Kubernetes space here. So.
Okay.
It takes a bit of time, but they will get there.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Hey, this is Jeffrey. Do you ever wonder if your software project is on the right path? It's really common for software projects to experience delays, to have the quality not where it needs to be, or have the team spending more time maintaining the software than you really should. And so in my practice, we know the challenges implementing all parts of DevOps, and it can make your head spin how many things you have to think about. And somewhere in your gut, you know that something's missing. So I've created a comprehensive 30-point DevOps inspection, reviewing your current process, methods, tools, source control, build integration, the various levels of testing, provisioning and maintaining environments, deploying, logging, telemetry, everything you need to think about in a high throughput, high productivity DevOps environment. And it really helps you gain peace of mind knowing that you're on the right track. And we are offering some more of our really popular 30-point DevOps inspections, and it's normally a $5,000 value, but I'm giving it away for free for my podcast listeners. Just send me an email, jeffrey@clear-measure.com. That's Jeffrey. And I'd be happy to inspect your existing DevOps environment, whether you use Azure DevOps Services, Octopus Deploy, TeamCity, any number of tools, because there are a lot out there. But what's important is that you have a complete and automated DevOps environment put together the right way. So get a second pair of eyes. Send me an email. So with so many applications at your firm, for how long should someone expect it to take if they say, you know what, I think we're gonna start a new application. Let's get it set up. Let's get the pipeline set up. We need to do some things in Azure DevOps. We need to do some things in specifying the AWS environment structure. Just getting in a place where a developer could develop the first feature. How long should it take these days?
Is for what we did at the firm is we standardized a few patterns. So if you follow those patterns, it will take you about 50 minutes.
50 or 15?
15 minutes.
15?
Yeah,
that's
15.
Not a lot. That's quick.
Yeah, then you're ready to deploy. But we had some templates you can pull in. And based on those templates, we can get you up and running and have you deploying to your dev machines. If you are outside of those standardizations, it's probably going to take you around a day. It depends on how much you're experienced. I've seen people with less experience take a week, and some other people that has experience takes a day or so.
Okay. And what were the points of standardization?
Actually, I was in luck when I arrived at the company that they already did some standardizations for the front end they had. They standardized how they do deployments for Java with Maven, and how their API are deployed. So I got 3 big areas where they're working on the company that already had a lot of standardization. So if your code is standardized and how you build it, I can quite standardize the pipelines for you as well.
Okay. And in Azure DevOps, are you using the new YAML format or the step-based pipeline format?
No, we went directly for the new YAML format.
Okay.
You see that let's call them more advanced engineers. They want it. There's no excuse. They want to be on the front line. There's no excuse for something else. It's not going fast enough for them. And it helps you. The biggest problem that solves is that you can branch the YAML file. So I changed my code. I changed how it needs to be built. I changed the YAML file, but it's not in my master branch, which builds a bit differently. But it builds for my feature branch. And the biggest problem I see with the less experienced engineers is they have less guidance how to create a YAML file, which UI version has a better solution for. But I do think personally is that the future lies in the YAML experience.
Okay. And so for people listening who are either they already have a system in AWS or they're looking to get in there, what would you say to the people who say, you know what, I'm just going to log into AWS and I'm going to create the environments using my browser and then I'll deploy to them?
Those people should go to a special place. So short answer, no. You need to have standardized how you because there are a few things before you put something in production. You need to test. You need to make sure that quality is there, etc. To make sure that you deliver something to your test environment, the same thing as production, you need to standardize. Pipelines help you with that, standardizing how you deploy. As soon as you standardize it, actually takes away the effort to do it manually. And we all know that we as humans are quite fallible. We make mistakes. And machines don't. Machine makes mistake because we make mistakes in them. But if we get that out of the way, the machine will do exactly what it needs to do, and is able to repeat it and repeat it. And the side effect is, if you take some deployment takes 10 minutes, you have time to get some coffee.
Okay, so you advocate provisioning environments from the get-go, from script, rather than even designing the environments and then at some planning sometime later to script it out.
No, just start from scratch. If you have an application, start from scratch as soon as possible.
Okay.
It gets you. It takes a bit of time in a start, but when you learn, it actually brings time back, so you can use that time to improve on other areas.
Okay. What's your favorite provisioning tool at the moment? Terraform, you use Puppet or Chef, or just direct AWS APIs?
So I've been using for AWS CloudFormation.
Okay.
I do have a preference for the tools. I need to remember the tool name, but there are some tools where actually you can code what you deploy and compile and test. I have a preference for those kind of tools because if you mention configuration code or infrastructure code, I emphasize on the code part. And Terraform and CloudFormation or YAML or JSON files, for me, that's not code. Code is something I actually can compile.
And debug and step through.
Yeah, step through. Maybe start unit testing them. So I don't really provision machines, but I can unit test them and mock out the actual implementation behind it. There are some promising tools. I have to come back on the names of the tools that actually should be able to leverage that experience. Everything has code. Okay.
Well, if the name comes to you, we'll circle back and include it in the show notes, because I'm sure the listeners would be interested. And I certainly am. Hey, there's tools and libraries where we can write procedural code essentially to build up and modify infrastructure. That'd be amazing.
Yeah, and think you can use your object-oriented experience to create not modules, but inheritance and such stuff.
Mm-hmm. Right. Okay. Now, once you provision an environment, and I don't think our industry as a whole has solved this problem, but once you provision an environment, what mechanism do you use to migrate it or change something about the environment? Because you don't just blow away every single environment and rebuild every single environment every time you go to production, right? Especially with the databases. The databases are the interesting part. You don't blow away databases. Maybe in the future, but currently many of us don't blow away databases. So you see that you see some schema changes there, which you can automate. Mm-hmm. But for the agents we did in production, we didn't blow away the auto-scaling, but we just told the auto-scaling,
now start using my new AMI.
Mm-hmm.
And the autoscaling starts to, okay, I know based on this policy you gave me before what to do with it. And actually starting turning off one machine, spinning up new ones, turning off two machines, spinning up two new ones until it's finished. So, and there are you got things like blue and green deployments, Kubernetes. If you are into Kubernetes, that there's a lot of things that helps you there, but you are still blowing, in your perspective, you're blowing away machines, but in a controllable fashion where you start substituting new machines.
Right. Architecturally, we can all imagine blowing away a Lambda and then recreating it and just essentially copying the executable compiled code into it, and it spins up. Compute elements are so easy to replace, but the elements that have state are not. And so one of the elements that it doesn't exactly have state, except that it does, is the networking configuration in your cloud environment. And so that is part of the overall environment that you would never just drop and completely get rid of and then put it back. And so you have to have some type of incremental change process when you do a deployment. Is that a solved problem?
I don't think so. We're getting better at it, but if you at a point need to deliver a whole new part of the network, which actually causes the old part of the network to be obsolete, I think you will have some downtime there. Because, there is state there, but you can't just blow away.
Well, how about the simpler things like adding or modifying a firewall rule? Or do you deploy those automatically?
We do, but if we have updates on those, we have experienced that we do had some downtime there as well. Again, you change the state a bit too stretched too far. That actually you need to get some downtime.
Yeah, that's at some point, and I can only dream. At some point, we'll have a situation where, hey, we need to spin up a new cloud data center or cloud region. Let me deploy everything, starting with the network resources, and then a particular application, then another one, and so forth.
So you do your blue clean deployments not on machines, but you do it on data centers.
Mm-hmm. Yeah, it'll get to that point.
Yeah,
the industry's learning every day. Awesome. Well, is there anything else that that you'd like to share as we're getting to the end of the podcast?
Yeah, I forgot to mention that the other effort we did is that you got the container jobs on the build agents.
Mm-hmm.
And we did some effort that the company started using those. The kits are build agents quite clean. And then pushing all those kind of tools that every team needs into containers. What we did is that we open up the projects that maintain those containers to everybody, and we started getting pull requests in there. Like, hey, if you need some change on those containers, give us some pull requests, and we will review it and we'll complete it. It also started creating a community within an organization. But the other part is that it's you go into a bit of was not complete inner source, but you go into that. And again, open source or inner source are quite hard to do. It's getting people involved to do the actual work. It's easier to give you a bug or an issue and ask you to solve them. And I have that same experience doing open source, and I got the same experience again. Okay, yeah. There are parts where people are really interested in helping out, but there are other parts where they say, well, please, can you do it for us? That was an interesting experience there as well.
Right. Okay. Awesome. Well, if people are interested in learning more about integrating Azure DevOps with AWS, is there any resources that you would point them to?
So there is the extension for AWS. maintained by AWS themselves.
Mm-hmm.
So that is a good start to read. And the other things we didn't document that very well. Sorry.
Hey, no problem. So you recommend that people browse into the Azure DevOps Marketplace and pick up the AWS extension, which will make things a lot simpler for using those, deploying to those cloud resources.
Yeah, and they did a good job into leveraging most of what they have in AWS and helping the community out.
Well, fantastic. Well, Jeffrey, I appreciate you coming on the show and sharing your success story with us. Thanks for the time.
Yeah, thank you too.
And if any listeners have a success story of their own or know someone who does, we love getting those on the show. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.